task is to find the sum of all minimums in all subarrays. We receive array as a list of integer, and we need to find the sum of all b minimum b, where b ranges over every contiguous subarray of array. Since the answer may be large, return the answer modulo 10 to the 9 plus 7. For instance, given this array, we can get this kind of subarrays, and for each subarray we need to find the minimum, and we just return its sum. Let's first find declare the mode. And in this task, each number can be minimum in some kind of subarray. For instance, 3 is minimum only in this subarray, while 1 is minimum in every subarray that this one exists. For that, to find the number of times this one exists in the subarray, we just find the number of previous elements, find the next elements, and just multiply these elements, which means that 1 is 1, 2, 3, 4, 5, 6 times. 6 times exists in some subarray. And to find the range in which this one is minimum, we can use previous and the next smaller element for that. So we need to find next smaller element for each element. This one stores next smaller element. To find the next smaller element, we can initialize it with n for each one, because we don't know beforehand what is the next smaller element, so we just say that it is somewhere after the 4. So initially, for all the numbers, next smaller element is out of the array, and we declare a stack for each I range. Let's also declare n in range n while stack exists, and the array of stack minus 1 while it is smaller than the array of I. Actually, while array of I is smaller or equal to stack element, we just pop the stack. And for NSE at I, we say that the next smaller element next smaller element is at I. So actually we take the top of the stack, and for this element at this index, next smaller element is at I. Then we just pop it, and then after popping we can insert new element into our stack. So this one will give us next small element. Let's just see what this one returns. Just prints. So next small element for 3 is at index 1 for 1. There is no small index, that's why it's 4 for it, for this one. There is also no smaller element for 2, and also for 4. Now let's find the previous smaller element, PSE, and for each previous smaller element, for all of them, we initially assume that there is no such element exists. That's why we just record it as the -1, so that indicate that it's out of the range. We do the same thing here, but instead of iterating from left to right, we iterate from right to left. For that, we arrange one, this one, this one, d1 is t, and the minus t minus 1 is, well, this one is bigger than the array of I. We can record it in a PSE, and get the top, and say that the previous smaller element at this index is current index. Then we pop the elements and do the same thing with and append the current element into our stack. Now let's see what PSE means actually. So previous small element for we don't have any small element for currently. We don't have small element for 2 either. Actually, we have this for smaller element for 4 is element at index 2, which is 2. For 2 small element is element at index 1, and for 1 small element doesn't exist, so that's why it's minus 1. For 3, it's also minus 1. Okay, so now we found the previous small index of previous smaller element and the next smaller element. So basically, for instance, let's say 2, 1, 4, 5, 3, and then 7, 2. For instance, for 3, this previous smaller element is 1, and the next smaller element is 2. So for 3 is to find the number of combinations, we just take the number of elements to the left, multiply to the number of elements to the right, and we get the number of times 3 is smaller than smaller. For that, we just iterate. You need to create some counter, which is initial 0. Then we iterate over our n, and the current element is array I. Left is going to be PSEI, on the right. Let's say count of elements to the left is going to be I minus PSE. Count right I NSE I minus I. So this is the number of elements till the smaller element. This is the same thing in the left, and the number of elements in the right till the smaller one. So for instance, in this example, for one number of elements is going to be -1 minus 1, which is going to be just the difference of these two numbers, and the p is going to be 2 for 1. Count of elements to the left, count of elements to the right is going to be n. And then we just find the number of elements So to find the combination of number of subarrays, as I said before, subarrays in which this element is smallest, we take count left times count right, and then we multiply it with the current, and then we have to take the mod. Actually, we can take mod one more time here. And then we just increase the counter by number of subarrays. And in the end we can also do mod. So yeah, that's the end of the submit. So yeah, time complexity for this solution is going to be linear. Time complexity is linear because we only iterate one. We only have only one for loop, and we have 3 for loops, but they are not. They execute line one by one. So space complexity is, time complexity is linear, and space is also linear because we only have just two stacks, and it is also considered as linear.